sharing that presentation with us. May I please invite Rennie back on stage to felicitate Mr. Mustafa for joining us for this conference and sharing those very informative nuggets of insights with us. Can we again have a round of applause? So I would request you to please take the center stage. Thank you. Over to you, Ravi.
Mustafa, we need to talk. There is any questions I can take? We have any questions? No? But we will sit down afterwards. I've a similar project, but in a snow region since a couple of years. So in Georgia. A high mountain connectivity. It will be interesting to share experience. So, we are in time. Perfect. So, hello, sir. You're waiting? Now we will talk about OOB networks, 45-year management network against security threats. Also very interesting. So, Mr. Mankal from OpenGear, he is his expertise are very clear from my point of view, developing and implementing the technical needs of a business, and with a, correct me, pre-sales background, right? So it's a good thing to combine sales and applications, and right now he is working as application engineer at OpenGear. So, please, it's your stage.
Hello, good evening. I am Sachin Mankal. I work as an applications engineer at OpenGear. You can see I also wear different hats. I do technical lead for the India and the SAARC region. Firstly, let me thank the SANOG and the India NOG committee for giving me this opportunity to present in front of such an experienced audience, along with prestigious colleagues who have given beautiful presentations today. And I will start with the presentation journey. So my topic today is about out-of-band networks, something which people sometimes don't think right out of the bat. Basically, out-of-band can easily complement your security concepts. It works hand in hand with the security that network can offer. So to people who do not know what out-of-band is, out-of-band basically gives you an alternate pathway or a separate, dedicated, secure access to your remote resources in case of your primary network is down. So when the primary network is down, out-of-band is what keeps you running. Let me start with some predictions and priorities that the CIOs and CTOs have for the upcoming years. The top of their list is the AI, the automation, and cybersecurity. With cybersecurity in the picture, they focus on majorly on ransomware, wherein the predictions for 2024 are $42 billion US, which will rise by up to 7 times in 2031. So if you look at the clock, below the clock, it says that ransomware is expected to attack the business or devices every 2 seconds by 2031, which is very critical. So that is why we need to secure our network. In the morning, Dr. Sanjay Bahal, he rightly set the precedence with cybersecurity at the focus, and the out-of-band solution works as a complement to the security part. Again, as per the experts, top 10 cybersecurity threats for 24 includes social engineering, third-party exposure, configuration mistakes, poor data management, ransomware is one of the most important in it, and so on. So what they expect is that the cybercrime cost or the damages that cybercrime is going to do will reach up to $10.5 trillion by 2025, which is almost more than 15% as it was in 2015, 10 years back. These are few real-life scenarios that have happened, the challenges that cyber attacks have caused. So one of a prestigious bank wherein the cyber attack took place, their app got stopped. No one was able to access the apps. The ATMs were shut. The POS systems were down. So people could not use their ATM cards or at the POS terminals, or could not access the ATM machines also to remove money. One more example is Virgin Australia, a famous airline. They had an attack on the network and they had to shut down the network. People could not book tickets, so it affected them very drastically. And then one more example is for a bank where it got attacked and the ATMs were stopped. So let me take you back in time wherein how the legacy networks were and how the out-of-band management had happened. So if you see on the screen, what we saw that during earlier days, we had a separate production network, we had a separate management network, and management network had console servers which would give you access to the serials ports of the remote devices. Over the period of time, this entire, both the planes shrunk into one. So essentially it was a production network out of which slices were taken out and management of the devices was done through it. However, this had an issue when it was a one single network. Since it was a single network, if any device, any appliance goes down, or if the network itself goes down, you are disconnected completely. So people again started going back with a separate management kind of plane, wherein it gave them a dedicated path. That is where an out-of-band solution again came into picture. But this time, it came with both serial as well as IP connectivity. So now the difference between the old out-of-band and the new out-of-band is that you also have a serial access as well as you have a management port access, which helps you to create a separate management network and have a dedicated path to all your remote devices. So we have taken certain examples in upcoming slides, which would help you understand the use case of out-of-band networks. This is the major, as I said, that the traditional network, it did not extend well to the remote sites, right? But with the new out-of-band technology, it extends not only to serial, but also to IP. That is what is covered over here. But there is one more aspect to it, right? Since if you have an out-of-band to a network, you keep on getting the questions like, what more can we do from an out-of-band? How out-of-band can help us in achieving security in the network or complement the security aspects of the networks? So that is what we'll take in the upcoming slides. Before I go into the upcoming slides, how the remote access started. I hope everyone remembers this sound. The sound is not playing. Sound is not playing. My apologies, but the sound is not playing. There is a link over there which is not playing. So we know the analog modem, right? There was a tee-too-too kind of a sound which ran during the earlier days, right? So you had a DB9 cable which connected to the, sorry. It's rolling on itself. No worries, thanks. So we had this DB9 cable which connected to the analog modems, and the modems would connect to the console servers, right? And then you dial into the model and you get the remote access the traditional way. So now that was an in-band kind of a management, right? But the disadvantage with an in-band kind of management, or if there's a cut in the cable, you're lost to the remote sites. So with an out-of-band with a dedicated kind of support, even if the primary goes down, you still have a path, external path to access your routers, switches, and devices at remote locations. So how can you achieve that, the modern network as compared to the legacy network? With having an existing out-of-band solution in your network, you can overlay that solution with a management fabric, which creates a separate management plane. And that plane not only manages your existing production network, but it also manages your connected resources that are there in the cloud, as well as in a virtualized environment. So one single point of management, one single point of control, and you can manage your entire network setting remotely anywhere in a place. As I said, we are going to go through the examples. So the first use case that I have for you over here is you having a network, isolated network, and an emergency access. This is one use case where the out-of-band provides you a dedicated path. Now, we'll do this in like first day, every day, and worst day kind of scenarios, how this use case works. So the problem statement here is that we know the networks, they have threats externally as well as internally. When I say internally, it is basically with reliance on a single network, which can create a significant vulnerabilities. Let's say the network breaks down and you are losing the connectivity. Though organizations have complex multi-layered protocols, security protocols, but they are all within the same network. And if a device, appliance, or a part of a network goes down, you lose the connectivity. So for example, if you see on the slide, you have a headquarter, you have plant area, and a remote site. In case of a failure of the connectivity to the remote site, you are now completely disconnected from the router switches that are there, and you have to run from post to pillar to go there to reach the site and check what has happened. With an OOB kind of a solution, wherein, as I said, that the OOB not only connects the serial but also the IP part of it, it provides a separate secured defenses for managing your network. Let me discuss with an example. So now the image that you see, it has got an out-of-band device in the network in all the 3 sites. It also has got a centralized management system at the NOC. In case of a link going down, you are disconnected. But with an OOB device into picture, the OOB device can fail over to a dedicated path through an LTE source. And this helps you to have secure access and transmit access from the NOC point to the remote devices. Basically, you can enter into your remote devices and do the configurations that are needed to remediate the setup. The second use case is basically having a secure deployment and a rapid recovery using out-of-band management. So we know that cybersecurity threats require a secure and resilient network. But that network should be also capable of doing a rapid recovery and a secure redeployment. So standard practices are we do regular patching onto the end devices and see that the vulnerabilities are removed. Let's take an example wherein an everyday case, right? Let's say it's a 0-day deployment. There are a lot of attacks that happen on the 0-day. And if it is your network and you are the first one to have that attack. So you are completely lost in this case, right? But with an out-of-band management, what you can do is you still have a separate management path to connect to your devices. You can rebuild the entire network using the out-of-band, as that is the first layer that will be in place for you guys to provide a secure path. You can run different scripts from the out-of-band server through a centralized path and configure all your devices. So that gives you a rapid recovery and a secure deployment path to establish your network again. The third one is monitoring, compliance, and stealthy security. This is the most crucial part of any network security requirements, right? You need to know what logs are generated, what devices you are monitoring, what ports you are monitoring and all. However, without an out-of-band setup, you are still doing in the same production network which does not have a different management plane. Let's say you have someone hacks into the network, or there is an inside bad actor who is trying to play foul with you, and you're not able to catch it. But with a OOB kind of solution, wherein you have a dedicated separate path for management networks, you can do secure logging, monitoring. You can check each and every port, log each and every configuration that is done, who has logged in at what time, what configuration changes has been done, can be completely taken out as a report, because the centralized manager of the out-of-band solution, it completely talks with an NMS system. You have API pulling can be done and the data can be fetched. This can help in generating reports that the leadership team might need for their visibility of the network. The last use case which I have is foundation of trustworthy operations. Now, with an out-of-band solution, this is a classic first day kind of a case, wherein the out-of-band solution is the first network that is deployed in this case, and you know that since it is a dedicated network, only people who need to have access will have access to the network. You can use this as source of truth for ensuring that correct configurations have been passed for each of the management devices, because this is a separate network from your production. So it also acts as a trustworthy operator or a source of truth for the network. Some real life cases that I have is, we had a customer who had a ransomware attack on their sites. The network was built with a traditional access to the devices. So when the attack happened, the person on the site was unable to stop it. And without remote access to the devices, the admin was unable to do anything. So they had to run from post to pillar to take evasive actions. After this attack, they introduced the smart out-of-band solution, which is completely having a dedicated separate path. This is cellular-based path access. This is completely different from your normal production path. With this, they are able to access all the remote devices daily. Every day they can do the logging part, the monitoring part, and this helps to generate them reports and give it to the higher management. The second use case I have is of a multinational customer who configures out-of-band devices on day one and sends them as part of the top-of-the-rack solution. So what they do is they have got multiple remote sites over here which are not manned. So they pre-configure the out-of-band device, enroll it into the centralized solution, and then place it into the rack. The rack is shipped to different locations. At the location, when the rack power is turned on, the device, based on the SIM connectivity, it latches into the central management system. And from the central management system, this customer manages, configures all the devices remotely without having a single person on the site. The only help he needs is to power on the rack. And he can do daily access of all the remote devices sitting in his head office or sitting anywhere in the world, because these are all on live IP addresses. So I leave you with 4 points for my closing, basically saying that out-of-band is a must to have, not a good to have, because it complements security really well. Cyber security being an ongoing daily activity, we need to take care that we are handling this equation very carefully. Organizations must have an alternate route to tackle the network downtime. And I leave you with last one line: don't use your production network to manage your network, but have a dedicated management network so that the life is easier. With that, I take your leave. Thank you so much.
Well, thank you so much, Mr. Sachin, for sharing that presentation. Well, smart OOB is must to have for networks. Can we have a round of applause for that presentation? And I'd like to invite back Rennie on stage to felicitate Mr. Sachin with a token of gratitude. So may I request you to please take the center stage? Thank you. Over to you, Rani.
I have the feeling you're running away, but it's okay, I'll take it. It's me. Again. And we are too fast. So, next one is waiting already. So, Mr. Umesh, IPv6 deployment. I'm really looking forward to it. So, enjoyed IPv6 deployment at NITK, Infrastructure and Application Migration. It's your stage, man.
Yeah, hello everyone. I'm Amog. I'm from NITK. I'm a final year CS student, and I'm part of the team that is deploying IPv6 for the campus. So I'll be presenting this. Okay, so what we'll be presenting today, the outline of the presentation mainly, the team that will be deploying IPv6, the plan of action that we devised to deploy to the entire campus-wide network, and also an overview of the current campus network and how it is currently. And also next we'll touch upon the project status, where we are at in deploying IPv6, how we are advertising our address block, and then how we set up a test bed to test various IPv6 DHCP DNS solutions for IPv6 deployment, and then also how we migrated our web servers and applications that we use in NITK in day-to-day life to IPv6. And also we'll then go to the next steps that we have planned to do in the coming months or so, some of which would be evaluating the performance to validate that our deployment is actually working as intended, and then analyzing IPv4 versus v6 hits, percentage of how much our traffic is v4 or v6, and then also migrating the remaining part of the internal network to v6. Yeah, so this is the overview of the team. We have 2 faculty members in this project, Professor Mohit Tahiliani and Soumya Hegde. So Mohit sir was actually supposed to present this talk, but I'm presenting instead of him. And we also have members from India Internet Engineering Society, or IIESOC, Dhruv Dodi from there. And we also have a student team, some of whom are here, apart from myself. Vinayak, Chinmay, and Rishi are also here. We also have an advisory team of consultants who are Nalini, Michael Ackerman, and then also 2 graduates, Akshay and Sushant. So yeah, this is the plan of action that we devised. First thing was to set up a test bed, a v6 only test bed, so we could test out basic IPv6 functionality before deploying it to the campus-wide network. Then would be to migrate services to IPv6, which would be the DHCP, DNS, and IPAM, and all other services to IPv6. Also, we are focusing on a dual stack deployment, and this would be to enable dual stack functionality in all the switches, L3 nodes, and all application servers as well in our campus. Finally, updating the web service. We run a number of web servers for academic purposes, and main websites and other applications. So migrating all of those to IPv6, and then migrating the VPNs that we use to IPv6 as well. And finally, this is also an important part, which was a detailed documentation to prepare, so others can also follow up and follow. It will help them in their IPv6 deployment as well, trying to deploy to campus networks. So this is the current network overview of NITK. So we have 45,000 plus user devices, a lot of them phones, laptops, lab computers. And we also have an upcoming expansion for NITK, and this is also something to keep in mind. So a lot of new devices would be added in upcoming years. And the current infrastructure overview, we have over 350 plus switches, 1,200 plus Wi-Fi access points covering all in indoor and outdoor regions of the campus. And then we also have a dedicated data center for the firewall and NAT and all the application servers and NAS storage devices in NITK. And this is the current infrastructure that will all need to be migrated to IPv6. Yeah. So coming to the dual stack deployment, our first priority would be to enable IPv6 on the public-facing web pages and sites of NITK, and this would include the main NITK website, the department-based websites, and then also our internal portal Iris. The next thing would be to migrate our internal core switch and all the backbone infrastructure, so we can also have IPv6 inside our network, and then would be to slowly migrate all of the internal network to IPv6 and then enable v6 on all the end clients as well. Yeah, so the tasks completed as of now. So we are currently using BSNL to advertise a prefix block. So we have a /32 for ourselves, and BSNL is advertising it. So we have v6 connectivity through them. And we have also set up a v6 only test bed to try out different experiments on v6. We have also compiled an inventory of all services in NITK, so we could identify any problems that would happen during v6, any services that might need to be moved away from or migrated, updated to a newer version. We also moved OpenVPN and WireGuard enabled IPv6 on both of them, and also migrated the main data center VLAN to v6. We have held a v6 workshop, so to help others who are also trying to migrate to v6 as well. So roughly there were 70 participants in the workshop, and they belong to various categories. They were in industries, government organizations, there were students and faculty members from other institutes as well. Each of them were given their own VLANs, and then they were made to set up DHCP, DNS, IPAM, the same way we would do in deployment. And this was the main workshop that we held in March of this year. The next thing was we migrated the data center VLAN to v6. All the routers, switches, firewalls, and NAS storage servers were migrated to v6. That has been completed. And this also allowed us to migrate the central computing server VLAN as well to v6. So all systems in the staff and the labs of NITK in CCC have already been migrated to v6, and they have been set up there. There's also a DHCP v6 server that has been set up to give DHCP addresses to all of these lab computers that are in this VLAN. Yeah, coming to the infrastructure migration, all switches and access points are slowly being tagged for VLAN, for dynamic VLANs to be set up. So IPv6 can be enabled on all of them. Once that is complete, we just configure IPv6 routing on each VLAN and then add users to this VLAN, add the deployment team and a bunch of beta testers, and then test the VLAN and the connectivity as well, and iron out any problems in this deployment. Once that is done, we can go ahead with a campus-wide deployment for all of this and start enabling IPv6 on a wide scale in academic buildings and hostels and all the Wi-Fi access points as well. This is an overview of the data center network of NITK. So originally we had a v4 only firewall, and then all of the infrastructure followed from that. So for v6, we set up a new OpenSense router, and that will only serve v6 traffic. So this is until we move to a new firewall, which also supports V6 as well. And the main migration for data center VLAN was to be done with the core switch cluster, which has already been completed. This is the test bed that we set up. It's a V6 only test bed. So we have a IPv6 over V4 GIF tunnel from the main OpenSense router that serves as IPv6 traffic to another OpenSense router that is only meant for the test bed. And after this, the test bed is completely V6 only without any V4 addresses. And we have 3 VLANs over there. And we have set up in DHCP, DNS, and IPAM in the 5 machines of the test bed. And in one of the machines, we have also set up VMs of different operating systems, which would be Windows and different Linux distros, and also Mac Mini as well for Mac OS. And in this test bed, we would run different experiments to see what was causing problems and how we can proceed. Yeah, so some of the testbed experiments are, first thing was we tried DHCP filtering in the intermediate switch. So we had a L2 switch between the OpenSense router and the machines in the testbed. And what we found was the DHCP DHCP request would be forwarded by the relay, which is the OpenSense router, across the VLAN into the DHCP server, but the reply from the DHCP server would still be dropped by the switch even after configuring DHCP filtering. This might have been a bug in the switch itself. We were using a TP-Link switch, and we would try it with a different switch is what we have thought of. Then we also tried neighbor discovery snooping. This is supposed to protect from ND spoofing attacks by creating a secure IPv6 to MAC address table mapping. And this generates this mapping once when the device first joins the network, and this mapping is constant throughout. And we tried this out, and this has been working as intended. There was also another problem with setting DNS servers through router advertisements. By default, sometimes via router advertisements, DNS is not being set, or it's being removed in the middle. And this was a problem. It was not working as expected. Yeah, so this is just a trace of the DHCP filtering. We can see in the DHCP server, we can get a request for DHCP, and the server replies with a relay forward. But in the OpenSense, which is our relay, we can't see the reply coming in. We can only see that the request was forwarded. And this probably is a problem with the switch that we were using. And yeah, so some of the other experiments in the testbed was, by default, Linux does not accept router advertisements. So we can't set up any sort of default gateway or anything using router advertisements. We have to make use of a DHCP server if we want to do it automatically. Otherwise, we would have to manually configure all of these systems to accept router advertisements. Most Linux distros do not ship with this, so they disable it by default. And even after accepting router advertisements, if a default gateway has been set up manually, the default gateway will still remain, and the gateway that we got from router advertisements would not be used in priority. So we would have 2 default gateways, and which one would be used would be the one that was set up manually. And the manually set up one would not even have an expiry. And so this was also another issue that we found was we would be forced to use a DHCP server for all of this. Yeah, this is just a screenshot of that happening. So we can enable router advertisements, and then once we do, another route shows up. So we have already set up a default route, but once the RA is enabled, the route shows up again, which is a link local address in this case through the router advertisement. And what we get is the route from the router advertisement has an expiry, but we are still using the route from the manually configured global IPv6 gateway. Yeah, and that has no timeout. So these are some sort of small bugs or nitpicks. So sometimes in OpenSense, when services are modified, restarting those services would sometimes not bring those changes immediately, and this was just something that we found. So some of these services would have to be restarted multiple times along with the chain. So one service being modified would not affect another service that would also be dependent on this service. And another thing was assigning an address that was already being used in OpenSense would sometimes throw an error saying the address was already being used, but oftentimes it would not really throw an error, and it would assign the address, but the address would soon disappear after 10 or 15 minutes. And this was also a problem where we couldn't exactly, the error was not outright visible. OpenSense also doesn't directly come with a default route that sends all traffic to WAN. So when once a WAN is set up, OpenSense wouldn't really have internet connectivity unless that route is set up. Not sure why this is the case, but this was also another thing that we found. The next thing would be to migrate applications to Iris. So Iris is like an ERP for NITK. All academic administrative activities happen in Iris. So Iris has around daily 25,000 plus users who use it, and most of them are students and faculty members. So what has been achieved so far for Iris? Support has been enabled for IPv6. All services in Iris and other open source applications that we use in NITK are on IPv6 already. And IPv6, the number of total hits that we got from IPv6 is around 12 million. This was measured over a period of 6 months and in last year. So there is two separate statistics here. One is before advertising our own address block, we were using Hurricane's IPv6 tunnel facility. So we have the total IPv6 hits, 12,700,000. That's including the Hurricane. And then the next one, after adding a quad A record for our own prefix, that is around 12,500,000. So it was for a short period of time that we were using Hurricane as well. And so hence two separate statistics. There's also total number of unique addresses that we got hits from to Iris from different ISPs was around 800,000 unique, 900,000 unique addresses. There's also ongoing tests in resiliency of IPv6, how resilient it is and what if any performance impacts that it has had. These are some other stats. So this is from the ISP side. What is the statistic of, in case of ISPs who are hitting Iris through IPv6? So we can see it is primarily Geo. Reliance Geo is at a majority, and then followed by Airtel. This is mainly from probably mobile devices and some fixed LAN IPv6 networks. There are two ways. One is through ISP, and then one we also got the org data from the ASN. So both are pretty similar. We see Geo as a majority on both of them. This is to do with the statistics for the clients that we got via IPv6 for NITK. And we can see majority of them are Android devices on the right here, and followed by Linux and then Windows. What is curious is if we check the total number of IPv4 clients that we have. We see Windows has the most number of hits via IPv4, and hence Windows clients are the most in campus, but we see not a lot of them are actually using IPv6 to access Iris, whereas majority of the Linux devices and Android devices that we have are using IPv6. Just something curious to see. Yeah. This is a status of migration of applications to IPv6. We use an Nginx reverse proxy and load balancer, and we just have to migrate this to set up all the public-facing sites on IPv6. We have added quad A records for Iris and NITK as a whole, and also our name servers. We also have set up reverse DNS for most of important services within NITK and the main reverse proxies of Iris. Then would be to migrate the Iris Rails app, which is the main Iris application itself, to IPv6. And then we also use an NFS server for syncing and all of this. And all the internal network of Iris has been migrated to IPv6. We have also migrated the Iris VPN to IPv6 as well. We used IP tables to forward traffic from one server to another for IPVPN, and IP6 tables is a very good replacement for that for IPv6. Some problem that we encountered was to migrate Docker applications to IPv6. So currently, it's not possible to properly set up IPv6 on a Docker because it makes heavy use of NAT. What approach that we have chosen for this is we can set up a unique local address for Docker applications within Docker, and then just map the ports for user enable. Like the host will have IPv6, and we'll have port forwarding for Docker applications, and then internally, of course, applications will be using the ULS to communicate with each other, and none of these will be accessible from outside. So there'll still be a NAT, but we'll have a NAT forwarding in place to migrate to Docker applications to IPv6. Yeah, so this is also the next step would also we use GitLab as the VCS, which was also migrated to IPv6. It's the same thing with IP6 tables for SSH for code in GitLab. And then we also have an ongoing migration of Kubernetes. The problem was we were using an older version of Kubernetes, which doesn't allow for dual stack services. And hence, the first step would be to migrate the Kubernetes, upgrade the Kubernetes version to a newer one before migrating to IPv6. We also have a staging server, which automatically spins up Docker containers as needed to set up staging environments for development of Iris. And this is also migrating to IPv6. It's just a Docker migration along with a bunch, since it uses multiple Docker networks, it's a bit more complicated. Some applications that we haven't yet explored feasibility of migration to IPv6 is Big Blue Button. We make heavy use of it for video conferencing and online lectures and video lectures. Also, another application was the main mailer software that we were using, which we have chosen to move away from now to migrate to IPv6. We'll be choosing a new mailer for it. So much for the IPv6 deployment. Yeah, thank you. If there are any questions, I'll take them.
Well, indeed, an intuitive presentation, Amol. Thank you so much for sharing your insights with us. Does anyone have a question in the audience? Anyone? Yes. Can you please pass the mic there?
Yeah, it's working. Thanks. Thanks for the good talk. Anurag Bhatia, Hurricane Electric. About your slides on Docker, IPv6 and Docker, you can make use of IPv6 in Docker without NAT, what you're looking forward is to have a routed address pool. So instead of having pool on the interface, you can get a big chunk routed inside your container and then utilize it without any NAT. It's just that it's more messy because you expect Docker to spin up network on its own without you having to touch the network. But it is possible. That's the point I wanted to make.
We didn't choose that network, that approach, because like we had multiple Docker deployments in multiple VMs. And so this would make our routing table quite messy indeed. But we also had another approach that we saw was there was a Mac VLAN driver
Right.
in Docker. So that also, is possible that we thought of. But just keeping this would make it a lot more simpler since we follow a reverse proxy based approach anyway.
Sure, that makes sense. Thanks.
Do we have any more questions from the audience? Anyone? All right, so on that note, can we give a big hand to Amok for that intuitive presentation? Thank you so much. May I invite Rennie back on stage to felicitate Amok with a token of appreciation. Would request you to please take the center stage. Thank you. And I'd like to invite Mr. Rupesh Shrestha on stage, please, to felicitate Rennie with a token of appreciation. Thank you so much. Thank you so much, Rennie. Do you have anything more to add? Any questions for Rennie? All right, thank you so much. Okay, so on that note, ladies and gentlemen, we come to an end of day one of SANOG41 conference. Well, I'm sure this day has been a day of extreme learning and knowledge sharing as well. From our discussions, starting right from very, very crucial segments, the opening address, we had with us the Secretary of Electronics and IT Government of India, Mr. S. Krishnan, who joined us virtually for his address. Followed by some very important addresses from our dignitaries as well to another crucial segments like navigating through the landscape of data centers with the Peering Forum 1 and technical sessions. That being said, tomorrow for day 2 SANOG41, we have yet another very interesting and important panels and discussions lined up for all of you. Tomorrow we take our discussions a notch higher. So I would urge everyone to please assemble tomorrow sharp at 9:30. We will be beginning with our day with some tea and refreshments and then with our panel discussions and sessions ahead. So thank you so much everyone for being such a warm audience at the day one of SANOG41 conference. And ladies and gentlemen, we have the cocktails and snacks arranged for you all at level 2, followed by dinner at the pre-function area outside from this room, starting from 6:30 p.m. So please enjoy your time, have a good evening, and I am sure I'm seeing you all back tomorrow at day 2 of SANOG41 conference. Can we end this conference today with a round of applause? Thank you so much. See you all tomorrow. This is MC Priya signing off for today. Thank you.